Do you feel like your answer is correct, or did you just grab that
I
one because?
I felt like it was correct because looking at the entire answer, the square because all four sides are congruent and adjacent sides are perpendicular. Because the other one that I was kind of considering it to be was rhombus. 'Cause it's kind of like rhombus, but then it says because all four sides are congruent, all adjacent sides are not perpendicular.
All right, well, the way to do this is you either have to look at it first through the lens of sides or angle. Okay, so for example, what I mean by that is are all the sides congruent? So you have to find the distance from A to D, or let me just do it yeah, let's just do it that way. What is the distance from A to D, B to C, B to C, and A to B? Did you find all four distances?
Um,
I didn't hear you if you said anything.
um, I did some right.
The 4 and 6. So this is a right triangle here. This one is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So this is another 4 and 6. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this is another 4 and 6. And I'm 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This is another 4 and 6. So these distances are all the same.
So if you
It's
were to use the Pythagorean theorem to find the
yes,
hypotenuse in this case would be the
they're all the square root of 52. So here's what that means. That means it's either a square or it's a rhombus. Okay. And the way you determine that is now from the slope. So you need the slope from A to B, and you need the slope from A to D. Because if they meet at 90-degree angles, then it's a square. If they don't, it's a rhombus. So the slope from A to B, we have it right here. It's 4/6, which is 2/3. From A to D, oh, sorry, that's the wrong square. Oops. The slope from A to B is down 6 and right 4 minus 3/2. Are these slopes perpendicular? It's minus 3/2 perpendicular to 2/3. Or maybe you don't know how to determine that.
yeah, I don't think quite yet.
Okay, so here's how you determine it. So there are two approaches. The first is that a slope and a perpendicular slope, if they are opposite reciprocals, then they are perpendicular 90 degrees. The other thing you can do is if you multiply the slopes and you get -1, then they're also perpendicular. So is this true? Is -3/2 times 2/3 equal to -1?
What would be other Yeah, I think so.
They are, yes.
Yeah,
And so when I say opposite reciprocals, that means you flip the fraction, like flip the 2/3, that make 3/2, and then you negate it to make the -3/2. So this is for sure a square, which I know is what you had, but you sort of have to know how to go down the path there of that.
uh,
Is that okay, or is that
yeah, they
all
kind of
right?
get it now how to like find it, how to like, it's actually. Um, So 3 is now, let's try.
Let's take a look here. How could you use coordinate geometry to prove that BD and AC bisect one another? BD and AC bisect one another. Okay. Um, bisect means they cut them in half.
Yeah, so for this one, it was either going to be proving the, I was going between proving the slopes are opposite reciprocals or proving, but I thought it wouldn't be proving the midpoints are the same because it wouldn't, because
The
AC is
midpoints,
smaller.
midpoints are the same though. That's what it means to bisect each other.
So the midpoint being like,
The middle.
so the
Like, okay,
midpoint's
here,
just referring to this like the middle of the,
let's draw a line segment. Does it have a midpoint?
yeah, the
Yes.
midpoint right there, yeah.
Now this other one also has a midpoint and it just happens to be in the same place. That's what they're saying here. The diagonals
Got it.
midpoint. It means that the segment on the left here is congruent. The top and the bottom here are congruent.
Got it. So this is number 4 now, which, there you go. This one.
Oh boy, it looks like a proof for something. Oh, here we go. All right. Wow. Okay. Quadrilateral is at E, F, G, and H. So what they're showing you here in, like, I would graph this. I would graph it just to kind of know what it is. But I guess they're saying it's a square, so you don't have to do that. But what they're doing here is they're finding the length from E to F, the length from G to H, F to G, and E to H, and they're all the same. They're 3 root 2, 3 root 2, 3 root 2, 3 root 2. Okay. EF, okay, has a slope of 1. GH has a slope of 1. That means that they are parallel. So when you prove that the slopes are the same, that means the line segments are parallel. That's enough here for you to tell me what 4 is. Because EF has a slope of 1 and GH has a slope of 1, EF is parallel to GH. That should be enough for you to tell me what number 4 is.
So EF and FG. Wait. Oh, wait 1 second. Let me take a look at
Sorry, which one?
I was just looking over the question.
I guess I'm trying to tell you, it's basically follows from three. Like it's the exact same. Three leads if you start from the one on the right here, leads to that. Three leads to four because it's the exact same thing about the lines being parallel.
Got it. Yeah, that makes a little more sense.
What do you think here?
Um,
Or is there any ones you can rule out?
you can probably rule out F, G, and E, H are perpendicular to G.
Okay, they're not perpendicular.
Mm,
You can also rule out this one because it's the exact same thing that's in three. You wouldn't have the same statement twice in a row.
yeah, the E, H, if you went F, G.
All right,
I
so I
would,
got to
yeah,
save the
I would,
suspense here.
I
It's
would,
this one
yeah,
right here.
I was
Because
gonna say it's, because after
so
looking at the expectation, you can kind of see where they were going at.
it's because the slopes are the same, so you can say that the lines are parallel.
Yeah,
All right. Good job on that. I know probably it gets like you look at all the stuff on the right, but it really can be greatly reduced in complexity.
all right, so this one, number 5. Yeah, number 5. Now,
Right. So Lydia graphed triangle LMN at the coordinates L, M, and N. She thinks LMN is a right triangle. Is Lydia's assertion correct? So did you graph this or not?
that one, not yet. I don't think I
Okay.
did.
So I'll graph it here for us and I'll drop a picture in. The graphing is super critical. Even if you just have a rough sketch of it on your paper without gridded lines, better than nothing. So we'll got it here. All right, so here we go. LMN. Sometimes your eyes will deceive you with what you think it looked like. So here you go. Here's L, M, and N. Now, it kind of looks like it could be a right triangle here. Do you agree with that? Like this could be a right angle?
Yeah,
So to determine if that is a right angle, you have to first find the slope from L to M, and then the slope from L to N. And you can do it either by counting, right? Like the slope from L to M is up to over 2, which is 1, right? Up to over 2. The big
yeah,
ones are the ones. L to N is down 1, right 2. So these are not opposite reciprocal. They're not um, they don't multiply to -1. They are not, it's not a right triangle. So we say, no, it's not. Oops. No, it's not. What do you think here? What's
Um,
the difference between B and D in this problem?
well, one of them says no slopes are says LM and LN are not opposite reciprocals. Another one says that they're not the same.
So when you have two slopes and they're perpendicular, it's because they are opposite reciprocals. That's what makes them right angles. So if it's
So
not
they
a right
wouldn't be.
triangle,
So they
then
wouldn't be
it
opposite.
would. Yes, that's correct.
And then it's number two. Yeah.
Yes.
Uh, um. Yeah. So this other one, I did end up graphing. Put it in the chat numbers. All right, it's in the chat now.
Okay. You said you did plot this one?
Yeah.
Okay, so one of the ways to do it is to literally just plot the points until you get the one that you feel like work. I don't know if you did this or not. What did you do to try to solve this?
Yeah, I think that's why I did it. I put like I put all the three original points, and then I first like already kind of went to the ones that were pretty obviously not it, and then kind of tried to narrow it down to the one that
That it is. Okay. Yeah, so let me do the same here. I don't have the ability to sort of mastermind where these points are without sort of seeing it. So here we go. I got a snip of it. All right, so what I'm seeing is the point could be probably somewhere over here-ish, like there, which is what you have. So yeah, that looks right to me.
got
The correct way to do it, like if it wasn't multiple choice, is you would want to figure out the
yeah,
um the parallel line through this point, the parallel line through this point, and figure out where they intersect. But you can kind of eyeball it when it's done this way.
yeah. So I did after like I took the semester one final. Okay, I did get to find out a bit about how like the finals are done for the specific class. So like I would say almost all the questions are multiple choice for this test. Like what I'm trying to get at is that
It's good to know.
there wasn't any written questions.
Oh, good.
So that yeah, so I kind of got to see kind of how the tests are like. So it's easier for like the next upcoming final, it's easier to kind of like guess what to spend more time on, what to
Great.
some that are like proof kind of in the chat now.
Yeah, so kind of like the way we've been doing this here. Uh, you kind of like, all right, so this one is which proof who is correct. All right. So to prove that opposite sides are parallel, parallel has to do with slope. So when you look at each of these proofs, which one calculates the slope?
Oh, the proofs. Russell's they, they
Okay.
said they
So
use
Russell calculates the slope. So the possibilities is that either Russell is correct or they're both wrong. Now
yeah
Russell's looking pretty good. Do you see how these are the slopes are the same?
yeah
What about these slopes? Are they the same?
Get rid of. I don't think they are because
-3/2, -2/3. Like it's kind of like, are they the same? Are they equal or not?
no.
No. Okay, so they are not the same. So they actually have not proved that their opposite sides are parallel. They've actually proved that, well, they just proved that they're perpendicular. So actually neither appear to be correct in this one.
God. All right. Nine.
Let's see, you sent another question in here. Go ahead and copy that. All right, which statement explains how you could use coordinate geometry to prove the opposite sides of a quadrilateral are parallel? So parallel refers to slope. Now I want you to look at the answers and figure out which answers actually refer to slope.
The first two refer to slope formula. I
So,
think the
so
difference between
parallel means same slope.
yeah, and then one of them says that to prove the slopes of opposite sides are the same. In other words,
So
opposite sides are
here's what
opposite reciprocals.
here's what they mean by that. The top and the bottom are opposite, and they need to have the same slope. The left and the right are opposite. They need to have the same slope.
Would be wait. Would it be number two then?
Same slope. Slopes have to be the same.
It's the same. Oh, so it'd be number one. Okay, so it's opposite sides are the same.
Opposite reciprocal means perpendicular.
So it means like a right angle almost.
That's right, 90-degree angle.
God. All right, so number 10, going to the chat. This is the last one for this lesson.
So looks like you already tried to answer this one, maybe.
Yeah.
Oh, all right. Which characteristic will prove triangle DEF is a right scalene triangle? Okay,
Oh, wait, actually, I'm looking at this right now. Wait 1 second, let me just.
so scalene means all different length. They're all different. So unfortunately, that means
So
that
it's
those
not
two are
number
out.
three. So no, it's not
Yes.
number three or number four. It has to be number one or number two. And it
So
says right.
right
So
means that there's the right angle. They're
so
perpendicular.
it has to be number two because that's the only one
That's
that
correct.
talks about opposite reciprocals.
That is correct.
Got it.
All right, I'm going to step away for 30 seconds, but I'll be right back. You can go ahead and
Okay.
drop the next one in the chat whenever you're ready.
All right.
All right, I am back.
All right. And next question in the chat.
All right, let's take a look here. All right, contractor's building a new subdivision on the outside of a city. He has started work on the first street and is planning for the other streets to run in a direction parallel to the first. The second street will pass through 1, 5. Find the equation location of the second street in standard form. All right. This actually wasn't even a geometry question, but kind of is. So what did you do? How did you try to answer this? Or did you just guess? That's okay if you did. I'm asking what did you do?
So for this one, how I got to x plus y equals 6. 1 second. Let me grab the here.
I'm not saying you're wrong. I'm trying to, find out what you did to figure this out.
I had it down somewhere. So paper away. Oh, weird.
All right. Do you want me to jump in and help here? I'm not trying to put you on the spot.
Yeah, I think I
All right. So
checked
parallel
that.
means same slope. So what is the slope of street 1? To define that, it's rise over run, which in this case, it's going down and then to the right, down and to the right. Can you tell me the slope of street 1?
The slope of street 1, it's down by 8 units, and it's to the right by 8 units.
Okay, which is -8 over 8, which is -1. Now notice you could have just gone down 1, right 1, down 1, right 1. And you would have gotten the same thing. Now, parallel means they have the same slope. Okay, so x plus y equals 6. If you solve for y, you get the slope. So solve for y, you get minus x plus 6. What is the slope of that one?
So that would be negative x, meaning that this it's plus 6, so it costs to the is 6 on the y-axis. That'd be -1 as the slope.
That's right. Okay. So -1 is the slope, which means that they have the same slope. So that's a good start. Now, does it go through the point 1, 5? When x is 1, is y 5? Like, does this work?
And x is 1, -1 times 1.
Like, is this true?
Yeah.
It is. So that works.
-1, yeah.
Okay. Now, you would have found, if you'd worked this out, that none of the others have a slope of -1. But let's just say another one did. You would have to make sure that it goes through that point.
Uh,
All right. When you're ready, I guess go ahead and grab another question, drop it in the chat, and we'll keep working on this stuff.
Oh, wait, I remember. For number three, I think I put it into dozens and just kind of checked it, seeing which can pass to the point that where it was five. That's what I did for that one. Anyways, number four is another, well, not exactly a proof, but it's not exactly a proof. Number four is in the chat.
All right. All right, here we go. I don't know what we're looking at here. Which statement completes step 6 of the proof? It'd be nice to know what we're actually proving here. Okay, we're gonna have to look at the answers first to kind of like go backwards. So they say the product of the slopes, the product of the slopes, the slopes of the slopes of. So we need to look at the slopes of JK and J prime K. So can you tell me the slope of JK, please, from the proof?
Slope of JK of right on the boundaries. -3/1.
Oh, it's in the proof here.
Oh, -1/3.
Nope, JK is 3. All right, here's J, here's K. You go from to find slope, you go
Oh,
from left to right.
negative.
So your rise is 3 and your run is 1. Up 3, right 1. It's also given here. Like I know students don't believe it, but I actually tried to not ever ask you something you shouldn't, like you can't figure out. Now let's have you do the same here. Let's have you do the slope of J prime K.
The slope of J prime K is -1/3.
-1/3. Okay. So there's 3 things that could happen when you're given 2 slopes. Okay. The slopes could be parallel if they are the same. They can be perpendicular if either the product, depends on how you look at it, product is -1, or they're opposite reciprocal. The third possibility is that they're nothing. They're just different. Okay. So are these the same? Are these slopes the same?
Those slopes are not the same.
They're not the same. So they're either perpendicular or they're nothing. Are they perpendicular?
Perpendicular.
They are perpendicular because their product is -1.
Got it. Oh yeah, it tells you that in the
So what is the answer?
uh, it'd be number one.
Is
The other one talks about KL and KL prime. Here's number 5. This one, what is the y-intercept of the line perpendicular to y equals 3 points x plus 3. Congruence this point 3 comma 1. What's the y-intercept of line perpendicular to line?
Okay, so the first thing is you got to figure out what is the slope of this given line.
The slope is 3/4.
Okay, now what is the perpendicular slope? So that's the opposite reciprocal.
So the opposite reciprocal would be -4/3, -4/3.
Okay, good. All right. Now, that's not what it's asking for. It could be, but it isn't in this case. All right. So the um it's asking for the y-intercept. So after we get the slope, we actually don't care about this line anymore. We actually don't care about this anymore. We just need the perpendicular slope, which is -4/3. So now we can write y equals mx plus b, y equals -4/3 x plus b. And you can use this x and this y to find b. You remember doing that in algebra 1?
Yeah,
Okay, so I want you to put 3 in for x, 1 in for y, and solve for b.
3 in for x and 1 in for 3 and 1 in. With the so putting the -4/3 in for m.
It's -4/3 is m, but you're putting 3 in for x, 1 in for y, and there's only one variable left over.
4/3 times 3 and plus b equals 1 plus 4 plus 4. That would be 5 equals b. B is 5.
B is, sorry,
B is 5.
good. Now b is the y-intercept. And that's what it's asking for. It's asking for the y-intercept.
So in this case, it'd be number 4.
Yes.
Yeah, number 4. Not just 5.
All right. Let's see if we can
For numbers, yeah. For number 6, I just want to make both of them equals x plus b, but here let me put it in the chat.
okay. All right, which statement explains how the lines x minus y equal 2 and y equals x plus 1 are related? What is the slope of the second equation here on the right?
1, positive
It's
1.
1 or maybe 1/1. Now, what I want you to do on the left here is I want you to solve for y.
Oh, for y, so this is x minus equals 2. Oh, so x, x minus y. All right, I got y equals x minus 2.
Okay. What is the slope of this one?
1.
It is 1. What do you know about the slopes now? What could you
They're the
say?
same.
They're the same. So what does that mean? Are they parallel, perpendicular, or same line? So
They're
same line would be if they were the exact same equation, which they are not.
so it's definitely not that. It's not number 3 or 4.
Okay,
See there, perpendicular. But the same. Here, let me y equals x minus y equals x minus 2, y equals x plus y equals x minus 2, y equals plus. They're parallel.
parallel, very good.
All right, I'm gonna jump back a little bit. Um, let's skip ahead to number 8.
Good. Is that in the chat? Oh, no, you haven't dropped that yet. Okay.
Yeah,
Yeah, we got a couple minutes left here, so just do your best here to,
okay, there's number 8 in the chat.
all right, let's take a look here. All right, so rectangle TUVW is on a coordinate plane such that AB +2 +2 +5 -1 +3. What is the slope of the line that is parallel to the line that contains TU? So if T and U are parallel, then V and W must be something. So we can find the slope of TU. Now, it probably looks worse than it is. It's still y2 minus y1 over x2 minus x1. Now t is a comma b. That's your x1, y1. And your u is a plus 2, b plus 2. That's your x2 and your y2. So that's b plus 2 minus b over a plus 2 minus a. So what does that simplify to? Take a look at that and see if you can come up with what you think it is. What do you have for me here? Still with me, Karthik?
Yeah.
So b plus 2 minus b is 2, a plus 2 minus a is 2. The b's cancel, the a's cancel, and that becomes just 1. All right, so we do have to stop here for today. We are all out of time.